Chemical reactions of biomolecule experiments. In this chapter, you learn variety of chemical reactions specific for three classes of biomolecules. Those are carbohydrate, amino acid and protein, and lipid. All the tests in this chapter is performed in a qualitative methods in which the positive and the negative controls are always required for unknown sample determination. Solubility test. Upon the receipt of an unknown sample, solubility test is a crucial method to roughly classify them. So, first of all, water and acetone solubility must be carried out. To do so, pipette 1 ml of either distilled water or acetone into 2 test tubes. Drop 5 to 10 drops of the unknown into each tube. Mix well by a vortex mixer. Observe the solubility, which is homogeneous in case of soluble, which is non-homogeneous in case of insoluble. Record the result. You should now know whether your unknown sample is water-soluble but acetone insoluble, or is water insoluble but acetone soluble. Carbohydrate and amino acid and protein are fallen into the former, while the lipid is fallen into the latter. Moleage test is the next step for the water-soluble but acetone insoluble. You can directly skip to lipid test if your unknown is water insoluble but acetone soluble. Moleage test. Moleage test is the test to differentiate the water-soluble unknown into carbohydrates or amino acid and protein due to its specificity for all carbohydrates. Fill each 3 test tubes with 3 ml of glucose, tyrosine, or an unknown solution. Add 2 drops of moleage solution and mix well on palm. Overlay with concentrated sulfuric acid in the fume hood. Observe the purple ring between the acids and the mixture interface. Compare the results from the 3 tubes. It might be amino acid or protein unless the moleage test results of your unknown is similar to that of the glucose. It must be confirmed with ninhydrin test primarily. Ninhydrin test. In case of your unknown sample water-soluble but negative for moleage test, ninhydrin test can potentially confirm whether your unknown is fallen into amino acid and protein. Fill each 3 test tube with 1 ml of glucose, tyrosine, or an unknown solution. Add 3 drops of ninhydrin solution into all tubes and mix well on pan. Boil all tubes for 5 minutes. Observe the dark purple, blue, or slightly orange-yellow solution. Compare the results from the 3 tubes. Chemical reaction test for carbohydrate. Iodine test. In order for polysaccharide test, starch solution, distilled water, and unknown solution were used as a positive control, a negative control, and a tested sample respectively in 3 test tubes with 2 ml each. Add 1 to 3 drops of iodine solution into each tube. Observe the color of the solution. That starch yield the deep purple-blue color. Benedict test. In order to test for reducing sugar, 3 test tubes filled with 3 milliliters of Benedict solution. Add 3 drops of glucose, distilled water, or unknown solution into each tube filled with Benedict solution to act as positive control and negative control of the tested sample respectively. Mix well. Boil all tubes for 3 minutes. Observe the reddish-orange suspension. All reducing sugar show reddish-orange suspension with Benedict test. Ferron test. In order to test for reducing disaccharide, 3 test tubes filled with 4 milliliters of maltose, distilled water, or unknown solution as a positive control or negative control, or a test sample respectively. Add 4 drops of 5% methylene hydrochloride into each tube and add 2 drops of 40% sodium hydroxide into all tubes. Mix well on palm. Boil all tubes for 1 minute. Observe the reddish solution. All reducing disaccharide use the reddish solution, while monosaccharide shows yellowish solution with Ferron test. Bell or Cyano test. In order to test the pentose, 3 test tubes filled with 1 milliliters of ribose, distilled water, or unknown solution as a positive control, a negative control, or the tested sample respectively. Add 2 milliliters of Bell or Cyano solution into all tubes. Mix well on palm. Boil all tubes for 2 minutes. Observe the bluish green solution. Pentose use the bluish green solution with Bell or Cyano test. Selivanov test. In order to test whether it is a ketohexose or aldohexose, 3 test tubes filled with 3 milliliters of Selivanov solution. Add 10 drops of fructose, distilled water, or the unknown solution into each tube filled with the Selivanov solution to act as a positive control, a negative control, or the tested samples respectively. Mix well on palm. Boil all tubes for 1 minute. Observe the reddish-orange solution. Ketohexose show reddish-orange solution with Selivanov test. Chemical reaction test for amino acid and protein. In case that the unknown sample shows a negative result from Molich test but a positive result from ninhydrin test, you are now confident that continuing further tests for amino acid and protein. Biuret test to test whether the unknown sample is protein or tripeptide onwards. 3 test tubes filled with 1 milliliters of protein solution, distilled water, or unknown solution as a positive control, a negative control, or the tested sample respectively. Add 1 milliliters of 10% sodium hydroxide in all tubes. Drop some 5% copper sulfates in a dropwise manner and mix well. Observe the bluish purple solution. Proteins and polypeptides from tripeptides show the bluish purple solution, while no reaction in amino acid with biuret test. Xanthopoietic test. To test whether the unknown sample is amino acid with aromatic R side chain, 3 test tubes filled with 2 milliliters of tyrosine, distilled water, or unknown solution as a positive control, a negative control, or the tested sample respectively. Add 2 milliliters of concentrated nitric acid in all tubes. Boil the tubes for 30 seconds. Cool the tube down by push the tube through the running tap water. Slowly add 2 to 3 drops of 40% sodium hydroxide. Observe the yellow solution. Amino acid with aromatic R side chain such as tyrosine and tryptophan show the yellow solution with xanthopoietic test. Hopkins Co test known as glyoxylic acid test. To test whether unknown sample is tryptophan and aromatic R side chain amino acid, 3 test tubes filled with 1 milliliters of tryptophan, distilled water, or unknown solution as a positive control, a negative control, or the tested sample respectively. Add 1 milliliter of glyoxylic acid into all test tubes and mix well on palm. Overlay with concentrated sulfuric acid in the fume hood. Observe the purple ring between the acid and the mixture interface. Tryptophan showed the purple ring with Hopkins-Cole test or glyoxylic acid test. Sakaguchi test to test whether the unknown sample is an amino acid with a side chain containing guanidine group, specifically arginine. 3 test tubes filled with 2 ml of arginine distilled water or unknown solution as a positive control and negative control or the tested sample respectively. Add 5 drops of 40% sodium hydroxide into all tested tubes and add another 5 drops of Sakaguchi solution in all tubes. Mix well on palm. Add 20 to 30 drops of bromine water. Observe the reddish solution. Arginine shows the reddish solution with Sakaguchi test. Nitroprusside test to test whether the unknown sample is an amino acid with R side chain containing sun hydryl groups, specifically cysteine. 3 test tubes filled with 3 ml of cysteine distilled water or unknown solution as a positive control, a negative control, or the tested sample respectively. Add 10 drops of 1% sodium nitroprusside into all test tubes and add another 10 drops of diluted ammonium hydroxide solution in all tubes. Mix well on palm. Observe the reddish purple solution. Cysteine showed the reddish purple solution with nitroprusside test. Chemical reaction test for lipid. Only when your unknown sample is water insoluble but acetone soluble, you can directly proceed to lipid test to identify more specific type of lipid. Glycerol test to determine whether your unknown sample is triglyceride. 4 test tubes filled with 2 ml of 1% glycerol as a positive control, cholesterol along with oleic acid as a negative control, or unknown solution. Add 0.5 ml of 1% sodium metaperiodate into all test tubes. Add 1 ml of acetylacetone reagent in all tubes. Mix well on palm. Incubate all tubes at 70 degrees centigrade water bath for 3 to 5 minutes. Observe the result from all tubes. Triglyceride containing glycerol units show yellow solution like the glycerol tubes with the glycerol test. Sakaguchi test to determine whether your unknown sample is cholesterol. 4 test tubes filled with 0.5 ml of cholesterol as a positive control, 1% glycerol along with oleic acid as a negative control, or unknown solution dissolved in 1.5 ml chloroform. Overlay with concentrated sulfuric acid in the fume hood. Observe the color ring between the acid and the mixture interface. Cholesterol show reddish orange ring with Sakaguchi test. Halogenation test to determine whether your unknown sample is saturated or unsaturated fatty acid. 3 test tubes filled with 3 drops of palmitic acid as a positive control, oleic acid as a negative control, or unknown solution dissolved in 1 ml of chloroforms. Add 5 drops of 5% bromine in methylene chloride. Observe the color of the solution. Unsaturated fatty acid like oleic acid spontaneously bleaches the bromine color, while the saturated fatty acid like palmitic acid cannot do so.